Hello world, this is Shauna with Disrupt Apps LLC with another PSA, Public Service Announcement and End User Education Series video. In this video, I want to talk about keyloggers again and how keyloggers can make encryption pointless and useless. And if you watch my first video, I went over the basics of keyloggers, but this is a supplemental video and follow-up video to that video. So I went ahead and, like I did in the last video, I made a dummy website. In this case, it would be a dummy chat application, and your favorite chat application, chat with your friends. Really simple, basic for demonstration purposes. Send message to, from Alice to Bob. And I've got an input box and a send and show log keystrokes. And then like before, I'll go over the domain, some basic code overview, nothing too heavy, just so you understand the principle behind how these things work. And then, I have my code here. But let's get started on this. So, the whole purpose of encryption is to hide and obfuscate, and scramble up your data so people can't intercept and read it. And that's how the modern internet works with like HTTPS protocols and SSLs and things of that nature. But what keyloggers will do is it will render encryption pointless and useless. Now let me show you a really basic diagram that I created here to show what happens when you actually type on your device. So this is your computer or smartphone, and I have this box here that kind of just represents like your laptop, your computer, your mobile phone, it doesn't matter. So basically when you type on your keyboard, you do your user input and hello world or whatever you type, and what'll happen is whatever you type is plain text, hello world is plain text. And your device will have an encryption algorithm that takes whatever you type in and it'll spit out a ciphertext. And in this case, I just put some random stuff to represent what hello world might look like from an encryption point of view. And then what happens is your device will send your ciphertext over the internet or whatever your network you're working on. And the internet, it's HTTP or HTTPS, which the HTTPS protocol is what you should be using in this case. But when it goes over the internet, it's going to go and be routed to the website or host or whatever network you're using. It's going to be routed to the target machine. So this is basically a really simplistic diagram flow path of what happens. So in the case of a keylogger, what's going to happen is, remember, we started with your hello world here with the plain text. So you see in here I've added this bad actor down here who's a separate entity. Now that bad actor may be a hacker. It may be someone within a company spying on you. It could be a three-letter agency. It doesn't matter. It's just someone who's a bad actor. And what they'll do is they'll get on your device somehow through a phishing scam or getting you to click on a link or install bad software, or they'll get in and do some sort of covert action to get and actually put it on the device. And there's so many ways to get onto the device, but they'll put a keylogger on whatever device you're using, or it'll get on your device. And what that keylogger is going to do is it's going to come up here, and in between your input, it's going to capture your hello world, your plain text, before it runs through the encryption algorithm. So whatever you type is going to be intercepted down here into the keylogger, and it's going to be funneled. Whatever you type is going to be stored on the bad actor server or the corrupted hardware. Like, they could basically collect your texts, your plain text on your mobile phone or laptop, and then every now and then they may send, phone home or send home what you're doing. So this basically if you have, end-to-end encryption, I mean, it'll make it useless because the keylogger is intercepting it before it goes into the encryption algorithm. So I wanted to get these two flow paths out of the way. So basically, here we have your favorite like a an example of what a simple chat app would look like. And here you have your text box. So, you would go out and send a message from Alice to Bob, period. And then I'm going to type hello world Z. And I'm going to show you why I did this, why the Z is important, just for the algorithm that I made here. So, you type a message, right? But I haven't sent the send button, which would send it over the network. And you would hope that this being an encrypted application would encrypt it. But like the other video, I had this showed log keystrokes. So here we go, boom. You have the shift, and then send a message from Alice to Bob. I have all my algorithm special X prefix and suffix here for the algorithm that I have. But, right here we have ciphertext sent only when you hit the send button, okay? So we haven't sent this we haven't sent this encrypted message yet. But let me pull up here my domain, go to MVC, and I'll go to the keylogger text, which this would be the keylog text that's being recorded without you knowing it before it's encrypted. So you can see here all this text, what you've typed, is in here. It's being stored to be looked after and sifted through later on. So now let's go back here. Now I'm going to actually hit the send button, which will actually encrypt the data and then send it. So I'll go ahead and hit send, boom. So I just basically did a really simple Caesar cipher. That's just when you do a character shift. In this case, I just did a character shift of 1. So it's nothing too difficult. I mean, you can see that this is the plain text unencrypted message, and then down here, what I did was I just did a basic Caesar salad encryption. No, I'm just kidding. A Caesar salad text, but A, you shift one key over, it becomes B. M, you shift one key over, it becomes N. So this would be just an example cheesy ciphertext that would be sent over the network, over the encrypted network, that would be hard for people to decrypt. If you're using AES or RSA or a proprietary algorithm. But just like I typed here, but realize the entire time you're typing your plain text or unencrypted text is being keylogged and recorded, thus making encryption pointless. A malicious actor is intercepting your keystrokes before your message is encrypted and sent. So, this is how, if a bad actor gets into your device, either through a scam or puts it there through social engineering, or physically installs it on your hardware somewhere, this renders encryption pointless. So now I want to go over. Let me go back over that diagram once more for reinforcement. Again, this is your computer or smartphone or device, this area here. And then whatever you type, in this case I just did hello world, it'll get piped into the encryption algorithm, and then that turns into ciphertext, and then it gets sent when you hit the send button over the internet or network to the host. Now, oops, and then when you have a bad actor that puts a keylogger on there, once again it intercepts it. So whatever you type, it's going to go get funneled through here, piped in here, hello world, H, boom, boom, E, boom, boom, L, L, O, and so forth. And it'll get stored on the bad actor server, or if it'll be stored on your device and accessed later. So that's just a high-level overview. And now just for some how this actually can be done. Now I do not advocate putting this code out here on the internet. This is only for demonstration purposes for people who are curious how this might work. Once again, I have the basic HTML code with the stylings, and you can see the stylings in the first Keylogger series or video I did. So basically, I code all my stuff from scratch. I just like doing it that way. I like the challenge of coding and the practice of coding. Just going through all the basic stylings here, and then we get to your all of your basic HTML elements. And again, this is the chat with your friends, send message to, from Alice to Bob. Then you have your text area, which, this is another time to do some teaching. And then you have your, text area box here. And then let me pull this back up. And then you have the dynamically rendered content, show logged keystrokes. You have type keylogged. And here's where I'm dumping my dynamically rendered information. So pretty trivial stuff for development. Beginner and junior level can do this kind of stuff fairly easily. Now from the Keylogger JavaScript, like in the first video, I do a special keys to see if I'm typing tab, and the volume controls, arrows, all that kind of stuff. So in this case, I did a basic Caesar cipher algorithm just for fun, just to show you a concept of how it works. And basically you make a characters or chars array of all the characters. And you'll see how this works later. And we've got detect keystrokes, which starts as an empty string. Then when you have add an event listener for a key down event. And then in this case, since I'm working with lowercase characters, I want to put everything in lowercase. So that's why I do the event keyed to lowercase here. And then I'm just, for simplicity's sake, I'm renaming the log key, and to make it easy to that, I'm just setting the variable to that right there. Makes it easier to deal with in the code. And then append keystrokes is just a secondary way of keeping track of everything, keeping the code in order. And then, this is the loop through that array up here to see if I'm doing a special key. This way I will log it as a special key, and here I'm putting it back to uppercase just for algorithm's sake. And then E repeat is if you hold down the key, whatever key you're holding down, it'll append and postpend or suffix, whatever you want to call it, the R to stand for repeat for the sorting algorithm. And then you're just basically, the detected keystrokes is getting, appended or concatenated with each key press. This one here is for the red flashing that you're being keylogged element. Ajax, do old school Ajax with the keystroke handler, which I went over in the previous video. But I won't go over that here because that's not the focus. And then again, I do add an event listener to the keystrokes button, which is here. And hopefully my camera won't freak out with blurriness. Good. So, and then I'm calling the get detect the keystrokes function right here, which is just getting the let's see here. Yeah, and then have a send button. Now this is what would kind of be mimicking if you sent, you know, when you hit the send button here, this would be sending it over the wire, over the internet to whatever server or website or host you're using. So that's what that's about. Now here's where they actually do the basic encryption. You know, the simple Caesar cipher. And basically what you do is you take the message you want to send over the internet, and you get the plain text value, and I basically get the value, trim it into lowercase, because I'm using the lowercase char set up here. And again, this element by ID is the plain text, which corresponds to here we go. The text area, I named it. Its ID is plain text, which corresponds to this text box input. So the message to send variable is going to take whatever your string you type into that text area box, and you need to get the length of that. That's why I have it set it to a length, because I'm going to use a loop to loop through that string text. So we're going to create an empty ciphertext, which this will be concatenated with each pass of the letter. And then I'm just going to do a basic Caesar ciphertext shift. And if you know about Caesar ciphers, you just basically take the alphabet and you shift over 1, 2, 3, 10 keys, and it's a really simple rudimentary encryption system, and I'm just going to do it for basic demonstration purposes. So don't go be putting this in the wild, and especially trying to do this on a JavaScript when everyone can hit F12 and read read your code and break your encryption. So, but again, this is just for demonstrations. So remember, we take your message, and each I'm going to loop through the message length. So basically, I'm going to message like hello world or whatever, and go through H, E, L, L, O, W, R, L, D. So each of those letters I'm going to loop through, and what I'm doing is I'm basically, each letter, I did a condition if it's a blank, just to concatenate a blank, because we don't want to, in this example, we're not going to encrypt a space. But if it's not a blank, then we're going to get the index. So like if A is typed on the ciphertext, A is in the input on the plain text, you know, we're going to shift it over to be B. And like if in the case of hello world, H, you find H, you shift 1, it's going to be I. E is going to be E, shift 1, F. LL will be you shift 1, MM, and O will be shifted over 1 to P. And that's just, again, a really simple, this is for demonstration purposes only to show you how this keylogger will make encryption useless. So right here in the real world, you wouldn't use a Caesar salad ciphertext encryption system. You would use most often AES or RSA or a proprietary system. So now, here's the fun part. If you type in Z, you need to wrap around back to A. And in this case, the index in the char set, the index of the index of Z is 25. Because, you know, arrays start with 0, 1, 2, 3, 4, 25. So if the index's value is 25, you need to make Z as A to wrap around. So that's why I did that right there. And basically you're just going to concatenate the ciphertext, and then, you know, you just do the index plus 1, you know, the shift value. You know, you're allowed to do addition within these square brackets. And again, I declare the shift value up here, and you can change this if you want, but this is for fun, you know. Anyhow, that's the encryption portion end, and then these are just displaying your ciphertext and the explanation up on the user interface. And then again, I like to programmatically create my my menu, my navigation menu items. So once again, really quick, this is the back end for the keylogger. You know, taking a keystroke, sanitizing it, you know, update the keystroke, you're opening the keylog text, you're concatenating to the text, and this is a neat piece of code to basically take your concatenated text, put it into the keylogger text file, saving it, and detecting if it's true or not. This is a pretty nice little concise, efficient code. But again, I do not advocate you using this code. This is just to give a basic understanding of how this is applied, how keyloggers can make and break encryption. And again, do not go putting this in the wild. This is for education and public service announcement services only. So once again, I do appreciate your time watching these videos. I hope you get some value out of them, and I look forward to more videos in the future. Thank you very much.